Congratulations, you have made it to the final video of Unit 1. Regardless of whether you were the first person in class to do this or the last person in class to do this, it's still an exciting moment. So good job, good work. This last lesson should be really simple for you. We're just going to be talking about some of the different systems of numbers that we're going to be working with this year. It is easier than our radical talk. It's just a matter of identifying what kind of number you're looking at. So I'll see you in a minute. All right, guys, I am so excited. I can't even tell you how excited I am for us to be at the last lesson of this unit. Not only because it's the last video I have to make for the weekend, but also because it's such a huge accomplishment. I know I already said this in the intro video, but man, I'm so proud of you guys for sticking with this crazy scheme of ours and making it to the last lesson of this unit. After this, only 5 more units to go. So let's go ahead and get into the lesson. Rational versus irrational numbers is the main focus. But before we get into really looking at what makes a rational versus what makes an irrational, I want to talk about some of the other number systems that we use in the 9th grade. Now, you'll notice that we have a lot of learning targets. It's not that simple, just I can subtract radicals or I can add polynomials or whatever. We've got a lot here. So the first thing is I can distinguish between rational and irrational numbers, and that is going to be the primary focus of this video. These other 3, where we're talking about explaining why the sum or product of rational numbers is rational and explaining why sum of rational and irrational is irrational, all of that stuff is going to be covered in the application video. So I know some of you sometimes don't take the time to watch the entire application video if you don't feel like you need it. For this lesson, it's going to be vital that you watch that application video. Mr. Thomaswick is going to be explaining these last 3 learning targets, and they are a big part of this particular topic. And they will show up not only on the mastery check, but also on the unit test, which is going to be your next thing that you have to do once you finish this lesson and this mastery check. You'll start preparing yourself for the first test. So it's really important that you do watch that application video, which will be found just underneath this video when you get to on the website. All right, so let's jump into the notes then. Our number system, and by our we mean the number system used in the United States and most of the modern world, is divided into several different classifications called sets. And you'll hear sometimes about what's called set theory or number sets, and that's just kind of how we talk about the different groups of numbers. The first set we're going to talk about today are the set of whole numbers. Whole numbers are your basic numbers that you think about. Those are the numbers you all like. Nobody's afraid of positive whole numbers. 0, 1, 2, 3, 4, 5, 6. They include 0, as well as all of the positive non-fraction, non-decimal numbers. So whole numbers are nice, right? We don't have to deal with fractions, we don't have to deal with decimals, we don't even have to deal with negatives because they're all positive. The scariest thing we got going is 0, which isn't really that scary. This next sentence in your notes was actually a mistake. So just go ahead and cross that whole sentence out. You don't need to worry about it. Sometimes you'll hear people refer to what's called the natural numbers, and natural numbers are the same thing as whole numbers except minus the 0. We didn't include them in your notes because you rarely have to worry about the natural numbers past like kindergarten. Once you've learned how to count, you can move past natural numbers and work with whole numbers. All right, so you will sometimes see whole numbers represented by this little symbol, this fancy little W here. All right, let's move on. So the next set of numbers we're going to talk about are the set of integers. I know you've heard this word before because in 6th and 7th grade when you start learning about those integer rules, what was it that we changed? Well, suddenly we brought in these negative numbers. So integers include all the numbers in the whole number set, but also all those negative non-fraction, non-decimal numbers. This can be represented this way, but basically those little ... means this goes on forever, getting smaller and smaller, -4, -5, but then also ... on the other side because they keep going up and getting bigger and bigger on the positive side. You'll also see it represented with this little z. Sometimes you might see us refer strictly to the positive integers, which, oh, all right, Positive integers, sometimes they'll just draw the little fancy z with the extra line there and then put a plus sign, or if I just want the negative integers, I might do the little z with a minus sign. But most of the time, you'll just see the z. All right, the next set is the set of rational numbers, and here's where we get to the focus of today's lesson. The set of rational numbers can all be expressed as a fraction, where p and q are integers. So think about what that means. That means a rational number is a number that you can write as a fraction, and in that fraction you have a non-decimal, non-fraction number in the numerator and a non-decimal, non-fraction number in the denominator. And it's important that you note that q cannot be 0 because, you know, we can't divide by 0, and a fraction bar is simply division. The sets of whole numbers and also integers are both included within the set of rational numbers, which makes perfect sense if you think about it, because a whole number we know we can write as a fraction whenever we do it all the time. If I've got the whole number 3 and I want to write that as a fraction, what do? I just pop a 1 underneath it. Now it's a fraction. Same thing with integers. If this had been a negative 3 and I wanted it to be a fraction, I'm going to do the same thing. I'm just going to pop a 1. Rational numbers are sometimes represented by this fancy Q, which comes from quotient, which is a way, if you know that Q represents rational numbers, that's a way of remembering that quotient is division. All right, our next set is, of course, the irrational numbers. And I don't know why we didn't make our blanks bigger. You can blame me for that because I'm the one that did that typing. But the set of irrational numbers are numbers that cannot be expressed as a fraction. This is very, very important because that's basically the difference. The set of rational numbers can all be expressed as a fraction. The irrational cannot be expressed as a fraction. Irrational numbers, you will know you're looking at an irrational number if the decimals do not terminate, which is just a fancy way of saying end. Let me write that in here for you. You should probably write it down too, unless you know that terminate means end, like as in the Terminator will end you. Decimals don't end. The decimals also don't repeat, meaning you can't get on the calculator that 1.333333. That is a rational number if it repeats like that. So here's a pretty little graphic. It's basically a fancy Venn diagram. Real numbers are all the numbers that we work with at this time. There are numbers that are non-real, but you don't have to worry about them in the 9th grade at all. Real numbers include basically everything: fractions, decimals, negative, positive, 0, whatever you want. Rational numbers are over here, and within the set of rational numbers you have the set of integers. So that means rational numbers are all your fractions and decimals, or fractions, positive and negative and 0 and everything. Integers take out that decimal portion and just look at the positive and negative. And then whole numbers is within the integers because you lose all those negatives and you just have your positives and your 0. Over here we have irrational numbers. Notice that this is not a Venn diagram in the sense that you're used to seeing that little intersection. There's no intersection there because there is no number that's both rational and irrational. It's one or the other. All right, so let me show you a few, well, it's one last thing. In Algebra 1, it's important to be able to tell the difference between rational and irrational. Just remember that rational numbers can be written as a fraction, but irrational cannot. It really just boils down to that. All right, so we have a list of numbers here, and I'm going to help you identify whether they are rational or irrational. When I look at this number 3, that is a rational number because it's a whole number. It's also an integer. So I want to say rational or irrational. I also want to tell how I know. Why is it rational? Why is it irrational? Square root of 16 is going to be rational because it simplifies to 4, which, as we know, is a whole number and also an integer. Square root of 17, though, is not a perfect square, and 17 is prime, so it can't be simplified. It is vital that you know that this is irrational and that all non-perfect square radicals are irrational. every single last one of them. If it's not a perfect square and cannot be taken out from underneath that radical, then it is an irrational number every single time. 4/5 is clearly written as a fraction. If it's a fraction, then it's definitely rational. This decimal has an end. It says 4.17 and then stops. Because it terminates, I know that it's rational. Now, take a minute, think about what I've said before, and try and think what I'm going to say on this one. We've got 4.33 and it's got that little line over it, which tells us that it's going to go 3, 3, 3, 3, 3. If your decimal ends or starts repeating, then it's rational. This last example has a decimal. It does not seem to end because it's got that dot, dot, dot at the end, and there also doesn't seem to be any kind of pattern. So that means it's not repeating itself. That tells us that this is an irrational number because it doesn't end or repeat. One last thing I want to tell you, sometimes students get into the habit of, if they don't see just one number repeating, then they think that it's irrational. But sometimes there was at least one problem we've done so far this year where your answer ended up being 5.454545 and so on. That is a repeating decimal. That is a line over that 4-5. So that would mean that this is rational, not irrational, because it repeats. It's only irrational if you can't find any sort of pattern and it goes on forever and ever. All right, so that's about it. Please, please, please make sure you watch the application video once you finish your practice because there's a whole nother concept that Mr. Thomas Wick's going to be teaching you there. Congrats again on finishing up the unit and good luck on your test.